Now, good morning, students. I think you remember yesterday I have uploaded some important board questions of ray optics. We are still doing with ray optics, discussing with ray optics, and I have uploaded some important questions. Right. We have almost come towards the end of the ray optics. I remind you, for this session, scattering of light is removed from the syllabus. I have uploaded the deleted portion of the syllabus also. You can consult that. You will get it there. So, I remind you, in our last class, we have discussed, our last discussion was the dispersion of light. In dispersion of light, we have seen that dispersion is the splitting of the white light or polychromatic light, which is consisting of a number of the wavelengths into its different color components. Alright, polychromatic light. Now, we have seen on that day the angular dispersion, dispersive power and all we have seen. I hope you remember, those notes are with you. So, today we are proceeding to almost you can say it is the last topic. It is the chromatic aberration. Actually, from the board point of view, it is not there, but when we shall discuss the optical instruments and all, in that this word chromatic aberration will come, and sometimes in competitive examination, there sometimes small problems on chromatic aberration may be there. In that context, I am doing it, right? Otherwise, directly it is not in the syllabus. Now, first of all, what is the chromatic aberration? Actually, chromatic aberration is due to the prismatic action of a lens, thin lens. A thin lens is supposed to be made up of a number of the thin prisms. Look, you see this figure. You can once see this figure. See this figure. In this figure, we can see that this lens is made up of a number of the prisms. Look, first prism, then second prism, the third prism. Here it is the middle portion of the lens. Okay, and some other prisms are here arranged in the opposition. We can think this thin lens to be made up of these number of the prisms. Right. These are the here. So obviously, what will happen when a ray of light will be falling on it? It will be like this. It will be moving towards the base, and ultimately it will go like this. Prismatic action. Look, it is falling in this way, horizontal line. Ray, it is being refracted towards the normal, and it is away from the normal. It goes like this. It's a convergent lens, convex lens. And in this way, we can say that it has the prismatic action. And actually, chromatic aberration is due to the prismatic action of a thin lens. What happens when a polychromatic ray of light, parallel polychromatic rays, fall on a thin prism? Then it splits up due to the prismatic action of the lens. It splits up into its different color components. Suppose a white light is falling on it, then it will be splitting up into the different color components. And here you can see the original direction is this. Here is the original direction. This is the maximum refrangible ray, that is violet. Minimum refrangible ray, that is red. Alright. So delta V is maximum, delta R is minimum. You can see the figure. So what will happen? Actually, till now what we have seen, that when a ray of light is falling, that is in this way, the parallel rays of light are falling, then what happens? They focus, these parallel rays will be focused at a particular point. But here what happens? The different colors are focused at the different points. We have shown two extreme colors. Violet, all violet colors are focused here at V. All red colors are focused at R. Alright? That's why what happens? Delta V maximum, delta R minimum, maximum refrangible rays violet, minimum refrangible rays red, in this way. That means there is not a single focus but a number of the foci. Understood? The plural of focus is foci. A number of the foci will be here obtained. This is the violet, this is the red, in between definitely indigo, blue, green and all colors will be there. Right? These are the different colors. So what happens? We are not getting a single focus but a number of the foci. This is the optical defect. Then definitely it is very difficult to locate a focus of this lens. Right? This is an optical defect. This is called the chromatic aberration. So obviously chromatic aberration is the optical defect due to which the rays which are falling on a lens are dispersed, right, and the different colors are focused at the different points. We are getting the colored images. This type of the defect is known as the chromatic aberration. Then definitely there must be some way of removing this chromatic aberration. The chromatic aberration, to remove this chromatic aberration, this is an arrangement in which, suppose a convex lens which is suffering from the optical defect chromatic aberration, to remove this, what we have to do? We have to place it in contact with a suitable concave lens. We have to place this convex lens in contact with a suitable concave lens. What is the meaning of suitable concave lens? Suitable concave lens means, suppose W1 or omega 1 and omega 2 are dispersive powers. I hope you remember. Dispersive powers of convex and concave lens respectively, and F1 and F2 are focal lengths of the same convex and concave lens respectively, right? Then it should satisfy the condition. The required condition is omega 1 by f1 plus omega 2 by f2 should be equal to 0. This is the condition. Look, this is the condition. If this condition is satisfied, then there will be no chromatic aberration in the system. If this condition is satisfied, that's why I say suitable concave lens, so that omega 2 by f2, right, plus omega 1 by f1, that will make that addition will be equal to 0. This is the suitable condition. This condition should be satisfied. Then only this is possible. And this condition which we are getting, this is called the condition for achromatism. What is the meaning of achromatism? Achromatism. The word achromatism means the removal of chromatic. Look, it means the removal of the chromatic aberration. The removal of the chromatic aberration is known as the condition for achromatism. Understood? So sometimes in competitive examinations, this thing is asked. Small numericals may be there, which is based on this. In CPSC we don't need it, but in competitive exams you may need. And moreover, in our, when we shall discuss this microscopes and telescopes, in that case there may be this optical defect may appear, we shall discuss. So obviously if you don't know anything about this optical defect, then it will be a bit problem for you. That's why we have discussed it. Alright, this is regarding the chromatic aberration. I hope all of you are agreed to this. What is the about this chromatic aberration? Alright.